We introduced Marcelle, a toolkit for the design of human interactions with machine learning. Marcelle's modular architecture allows developers to compose custom workflows using interactive machine learning components. As a toy example, we can easily build an image classifier from a webcam and embed it in a musical application. We illustrate Marcelle through two scenarios. The first scenario involves a SIGCHI researcher who prototypes a sketch recognition application to run a study. The second scenario focuses on the collaboration between a machine learning expert and a clinician to build a skin lesion classifier. In our first case study, we show how Marcelle can support rapid prototyping of interactive machine learning workflows. Marcelle is a JavaScript library and only requires a simple script to define an app. Components are instantiated using factory functions. They provide views that can be composed into custom layouts such as dashboards. In this example, we create a sketchpad, a dataset, and widgets to capture labeled sketches into the dataset. While components are visualized, they do not yet communicate with each other. Marcelle uses reactive programming for the design of pipelines that link user interactions with machine learning processes. In this example, we use a button's stream of click events to sample the sketchpad stream of images. Combined with the label from the text field, we obtain a stream of instances that can be fed to the dataset component. With new JavaScript libraries such as TensorFlow.js, it is possible to run training and inference in web browsers. Marcelle provides models that can be trained from the user's data without need for a remote server. Marcelle also provides visualizations that can be applied to components or streams, for instance to monitor the training and to visualize predictions in real time. With this architecture, developers can rapidly experiment with various workflows. Recomposing the app layout can be done by changing the component's order in the dashboard. Pipelines can be modified for incremental learning. Predictions are updated at every stroke on the sketchpad, and changes to the training set trigger the model's retraining. The second case study illustrates how Marcelle can support collaboration between machine learning experts and domain experts such as clinicians. Marcelle provides a Python package enabling machine learning developers to record training logs and model checkpoints into a data store. This data can then be accessed into a custom dashboard to monitor and compare machine learning experiments. Particular model checkpoints can be loaded in the web browser for direct interaction. Custom pipelines and interfaces can be created to inspect a model's behavior with particular instances or with arbitrary datasets. The creation of components and pipelines can be abstracted into functions. Pipelines can therefore be reused, for instance, to create side-by-side model comparisons. Marcelle's data stores can host data in browsers' local storage or on remote servers. They provide real-time data synchronization, allowing machine learning experts to instantly share their progress with clinicians. Dashboards can be tailored for clinicians, allowing them to interact with a trained model and to correct misclassifications. By synchronizing datasets, model developers can easily gather new annotated data from clinicians.